Good morning everyone. This video is about 8.3 proof for parallelograms. In this video, I would like to talk about some challenging questions in exercise 8.3. Before that, let's try to review on what are the conditions that we can show a quadrilateral is a parallelogram. So we have 4 conditions. No, actually we have 5 conditions. So you can have a look at these first. And the 5th condition is, if you can show that there are 2 pairs of parallel lines, then you can claim that ABCD is a parallelogram. Why? Because this is the definition of a parallelogram and there is no reason needed. So in this exercise, we are going to look for the conditions that we can show that a quadrilateral is a parallelogram. Let's start. First, I would like to talk about number 1 from exercise 8.3. Basically, I would just want to tell you how to present and give you different ways of proving a parallelogram. If you find this too easy, you may skip to the solutions directly. For 1a, it is so straightforward that you know the 2 opposite angles are given to be the same. So you can just write like this. So I show you the presentation. Because the 2 angles are equal, you have to write the reason given. 2 angles equal. And then you can claim the conclusion, and then the reason should be put after the conclusion. So this time we make use of the second condition because we have the opposite angles equal. So you can write like this. Well, but apart from this, I also want to show you method 2. Method 2 is that if I can use the sum of these 2 angles to prove parallel lines, and then sum of A and B angles to prove another pair of parallel lines, then we can claim because both lines are parallel, both pairs of lines are parallel, so you have ABCD is a parallelogram. And you can see that there is no reason needed because it is by definition. So you can choose either one method. Look at part B. Now you have already 1 pair of opposite sides equal, and then you can see that there are 2 angles given here, and the sum of them is equal to 180 degrees. It means that AD can be proved to be parallel to BC. It means that you can look for condition 4. We have 1 pairs of opposite sides equal and parallel. Okay, so now you can check for the presentation. I first prove AD parallel to BC because of interior angle supplementary. And then we have to write because there is 1 pair of lines equal, 1 pair of lines parallel. They are the same pair of lines. And then you can draw the conclusion and write the reason after that. Okay, and now I give you the presentation for part C as well. This is really easy, so you can look for it yourself. We just need to write out the given conditions, which means AE equals to EC and BE equals to ED with the words given here. And then you draw the conclusion. Diagonals bisect each other is the reason for that. Now let's look at number 4. This is a question for assignment, so I just give you the hint and tell you some common mistakes that you may have. Let's look at part A. You want to find x, and then I always see some students would try to find x by interior angles, parallel lines. However, it is not possible because you don't know ABCD is a parallelogram yet. You only see that this is a random quadrilateral. Okay, so it means you have to abandon this idea. What you need to think is what's true for every quadrilateral. So you can make use of this angle sum of polygon because it is true for every quadrilateral. So after you find x, then you can look for the opposite angles and claim that ABCD is a parallelogram. Opposite angles equal. So you try to complete question number 4 yourself. Okay, now let's look at number 8. Your goal is to prove AMCN is a parallelogram. So obviously you can see that because ABCD is a parallelogram, you have 1 pair of parallel lines already, which is AM parallel to MC. This is given condition. So what you need to show is another condition, which is AN equals to MC, because both of them are midpoints of the 2 sides of a parallelogram. It seems obvious, but you still have to write clearly the steps. So let me show you how to present in these questions. First, you can claim AD equals to BC because of opposite sides of parallelogram. Why we can claim so? Because ABCD is a parallelogram, this is a given condition. And then you must show that AN equals to 1 over 2 AD, MC equals to 1 over 2 BC. Both of them are given conditions because they are midpoints. So you can draw the conclusion that AN equals to MC. Finally, you can write because AN equals to MC and AN parallel to MC. This is given because you know that ABCD is a parallelogram, so you can write given here, or sometimes if you skip given, it is fine. And the MCN is a parallelogram. The reason is opposite sides equal and parallel. Okay, now let's look at number 9. This is a very interesting question because from the diagram, you already have two parallelograms. And then you try to prove that ADEF is a parallelogram. So why I say this question is interesting, because you can see that you can treat BC as the middleman. Because ABCD is a parallelogram, so you can look in the diagram here, AD equals to BC. Because BCEF is a parallelogram, and then you can look at the diagram here, FE equals to BC. So when you draw these two in the diagram, you can see that FE equals to AD. Similarly, you can see that AD parallel to BC, BC parallel to FE, then you can claim FE parallel to AD. So now you have two conditions here, and you can use condition 4 to prove for parallelogram. Okay, so this is how I present my answer. You have to write the reasons here. Don't mix up the reason. You have to write opposite sides of parallelogram. Don't write equal here. And then after you draw the conclusion that FE equals to AD, and then you can also say FE parallel to AD because both of them are given. Why given? Because you have no other reasons for that. They are parallelograms, so they are parallel lines. Okay, so you can say because FE equals to AD and then FE parallel to AD, then you can draw the conclusion. Reasons should be put after the conclusion. Okay, now let's move on to level 2, and I can say that all these questions are extremely hard. I don't mind you copy the answers from me as long as you watch this video seriously and think seriously what I write. Number 10 is extremely challenging, I think. So first of all, you have to look at the given condition, which is a congruent triangle. Okay, so when you have a congruent triangle given, I hope that you can think about the 6 conditions given already. These 6 conditions should come into your mind because you already have them. But of course, you do not need to write all of them. You just need to pick the one which are relevant. Okay, so let's look at part A. AFED is a parallelogram. So which of them will be relevant to part A? The highlighted part is the parallelogram that you want to prove. So you may find that this condition, AF equals to DE, may be relevant. Now you have one pair of opposite sides equal. However, you cannot claim AD equals to FE easily. So you may look for another condition, which is you try to prove AF parallel to DE. So how to prove parallel lines? You can use interior angle supplementary if you look at these two angles. If the two red angles here add up to 180 degrees, then you can claim AF parallel to DE. But how? It may be very challenging to present your answer, so try to have an analysis first. Because of the congruent triangle, you can say these two angles are both x. And then the red angle here can be written as angle BAD minus x. And then you can look at the green angle here. You can say this angle is equal to 180 degrees minus angle BAD. The reason is you have one pair of parallel lines given already because ABCD is a parallelogram. So you can say interior angles AB parallel to DC. So after this analysis, you can look for angle FAD plus angle ADE. Then you can just write down here. And then after that, you will find a very interesting fact. You can see angle BAD cancel away, x cancel away, and the answer is 180 degrees. Then you can draw the conclusion here, interior angle supplementary. Okay, so this is just the idea. How to present? I will show the answers now. So this is the answer, and please look at it carefully. You have to write every line clearly by stating the correct reasons, like this: corresponding sides, congruent triangles, corresponding angles, congruent triangles. After that, you can let x in order to present it well. Of course, you can just skip let x if you want to write angle BAF, angle CDE, that's fine. And then this is just like what I said before. And then you have AF equals to DE, AF parallel to DE, then you can draw the conclusion. I think this may be the simplest way already. Of course, it looks very complicated. Okay, after you prove part A, part B would be easier because you can make use of the result of part A, and part B would be just very similar to question number 9, and I believe you can try yourself. The logic is just the same as question number 9. You can take BC as the middleman. You can claim one pair of opposite sides equal and then one pair of opposite sides parallel, the same side. And then you can refer to how to present in question 9. So question number 10 is very scary, isn't it? So I hope it hasn't scared you away yet. Let's smile. Yay! Now look at number 11, which is also quite challenging, I think. So the given conditions are two congruent triangles. Again, I want you to think about what are the given conditions. For each pair of congruent triangles, you have 6 conditions each. And then you are going to look for the conditions which are relevant to the parallelogram that you are going to prove, EFGH. I think in this question, these two ways are both possible. If I use the first way, opposite sides equal, then you have to look for the corresponding sides of congruent triangles. You may mark all of them in the diagram. From the congruent triangle, you can say BF equals to DH because when you look at the first pair of congruent triangles, you have BF and DH equals. And then you can look for DE equals to BG as well because you look at the second congruent triangles. You can say the two blue lines here are equal. So you can say FG also equals to EH when you have one minus the other. Similarly, you have AE equals to CG and then AF equals to CH, and you can also draw the conclusion EF equals to HG easily by one minus the other. However, the presentation is quite tedious though, so I don't want to write for you, so you can try yourself. The idea has been given to you. Now let's look at the second condition. I think this one may be slightly easier to present, but the idea is quite similar. You can look for the corresponding angles here, which is AE dot and CGB. They are the same. So when you have the adjacent angles on straight lines, they should also be the same. It means the two blue angles here are the same. So for writing this, you have to present very clearly like corresponding angles, congruent triangles, and then adjacent angles on straight line, adjacent angles on straight line. And then you can claim that the two blue angles are the same. Similarly, you also have AFB equals to CHD, which are corresponding angles, congruent triangles. And then adjacent angles on straight line, adjacent angles on straight line, you can claim the other two angles being the same. So you have opposite angles equal. So if you want to refer to the presentation, you may check this out. This is from the model answer and I don't want to write myself. But the ideas is just the same as what I spoke just now. Okay, so now let's look at number 12. I want you to put some stars here because it is the most exam type questions that you will find, and this is not really that challenging. However, sometimes you may find A is skipped. It means that you have to think about the congruent triangle yourself without any hint. But this question is a good one because it shows you part A. With a hint here, it is not that hard. So how do we prove congruent triangle? We try to look for the 6 conditions. Out of these 6, we want 3 only. SAS, SSS, ASA, AS, RHS, and so on. No, so on. Okay, so you can think about which 3 conditions you have. Okay, so I give you the answers about it. First, obviously you have one angle given already. And then next, you can claim that AD equals to BC, or actually AD equals to CB. Why? Because they are the opposite sides of a parallelogram. And finally, you can also claim these angles and the corresponding one equal because they are alternate angles, AD parallel to BC. So after you claim all these 3, you have SAS to prove the congruent triangles. After you prove congruent triangles, part B would be quite easy for you because after you know these two triangles are congruent, then you have AF equals to EC corresponding sides congruent triangles. So you have two pairs of opposite sides equal, then you have opposite sides equal as the reason. So you can write the answers yourself. I think I do not need to give you the answers here. Let's look at number 13 here. For this question, I may give you the answer because the presentation may be quite tedious and some of you may mix up some of the reasons. So I want to clarify something about regular polygon first. Suppose ABCDE is a regular pentagon, then what can we claim and what reasons should we use? So please note that here. Of course, all these five sides are equal, but suppose I want to claim, let's say in particular, AB equals to BC, what reason should we use? We should write given, because it is the definition of a regular polygon. Next, in particular, if I want to find angle ABC, the angle is 108 degrees, then what reason should we use? We should use angle sum of polygon. Note that we have to divide by 5 because it is each of the 5 interior angles and each of them has the same values. Of course, if you want to claim more than one angle equals to 108 degrees, you can write like this. Angle BCD equals to angle ABC equals to this. Of course, you may not need to write all the 5. You only need to write the relevant ones. And the reason is still angle sum of polygon. So I think you can do part A easily now, and I'll also show you the steps. There is one remark here, because if you want to show angle ABC equals to angle DCB, you can just write given. But just now I told you you can write angle sum of polygon. Of course, if you want to calculate 108 degrees here, it is fine to use that reason. However, for part A, we do not need that actually. So I write in a simpler way here using given. Okay, for part B, the presentation may be quite tedious. However, the logic is not really that hard. Look at the diagram clearly and see what information we have on hand. After I draw all these information here, well, the things becomes much clearer. First, we use angle sum of polygon to calculate that these two angles are 108 degrees. And then we make use of the fact that ABC is an isosceles triangle, BCD is an isosceles triangle. Then we can look at the base angles isosceles triangle. It means that we can calculate that all these angles are 36 degrees. Of course, the presentation may be quite tedious, but the logic behind is quite simple. Finally, you can calculate angle BFC by angle sum of triangle, vertically opposite angles, and you can get this one equals to 108 degrees. Okay, so I write up to here first. You can claim these two angles are 108 degrees because of angle sum of polygon, and then you can write out the three lengths equal, which will be used for proving base angles isosceles triangle here. So when you prove these two angles are 36 degrees, you have to write two reasons. So please follow this way of presentation as you learned in last year. You have to first claim that they are equal because of base angles isosceles triangle, and then you have to write angle ABC. Why? Because this is a proof questions. It means that every presentation would be very strict. You have to write 180 degrees minus angle ABC. The reason is angle sum of triangle. So don't combine these two lines together because you must write them separately with two separate reasons. And then you write 180 degrees minus 108 degrees. You can calculate 36 degrees here. And then you can claim the other two angles equals to 36 degrees as well, but the steps are too tedious, so you try to do it yourself. I don't give you the answers now. Okay, now let's look at part C. Your goal is to prove AFDE is a parallelogram, and quite obvious that you can make use of the result of part B here. So according to part B, obviously you will have one pair of opposite angles equal, and then you just need to calculate the other two angles here. They can be calculated as 72 degrees easily because you have 108 degrees minus 36 that you have found already. It means that for this question, we make use of opposite angles equal to prove for parallelogram. Okay, so you try to write clearly the presentation. Remember that this is a proof question, so you have to write all the angle names clearly. Okay, now let's look at number 14. For this question, you may refer to 8.6 midpoint theorem. However, because it is not learned yet, so I would not use this theorem for this question. But you can refer to this idea later when you learn 8.6. Look at part A. In order to prove these two triangles are similar, we may make use of the reason ratio of two sides included angle. I think most of you would forget already, so let me review what this is. So if you want to use ratio of two sides included angle, you have to check the ratio of AD over AB and then AF over AC. You can see that both of them are equals to 1 over 2 because D and F are the midpoints. Then you can claim angle DAF and angle BAC are equal because they are the common angles. So how do we present the answer? Let's follow this. Okay, so now you can refer to the presentation in part A. Now let's look at part B. If you want to prove parallel lines, you can look for the corresponding angles of the similar triangles. It means that the two green angles here are the same. Look at the original figure. You can claim angle ADF and angle ABC are the same. Because they are the corresponding angles of the two parallel lines, you can say corresponding angles equal to proof for parallel lines. Okay, so the presentation is here, but please note that the two corresponding angles here are actually different things. The first corresponding angles are referred to the corresponding angles of similar triangles, but the second corresponding angles are the corresponding angles of parallel lines. Okay, so this is how we present. Okay, now let's look at part C. You want to prove this is a parallelogram. You already have one pair of parallel lines. So for part C, there are two approaches. The first approach is that you can copy all these part A and part B again, and then you try to prove another pair of parallel lines which are BD parallel to EF. You can just follow exactly the same thing as part A and part B to prove so. However, I don't want to use this method. Our goal is to show DF equals to BE. This is my way. We can use corresponding sides of similar triangles to show that. Look at the diagram here. Because ADF and ABC are similar, so you can also say DF over BC is 1 over 2 because AD over AB is also 1 over 2. This is because of corresponding sides of similar triangles. It means BC equals to 2DF. And then you also know that BE is the midpoint of BC. So you can say BE equals to DF. Alright, so this is the idea, and now I present the answers for you. Okay, so you can follow the presentation here. First, you have to claim corresponding sides of similar triangles to show that DF over BC equals to 1 over 2. And then you have to show that BE is the midpoint with the reason given. So you can show that BE equals to DF. Also, you can claim BE parallel to DF because from part B, they are the same pairs of parallel lines. So this is the conclusion, and then the reason after the conclusion. Finally, let's look at number 15. But I don't think this is as hard as the questions before, so first of all, please erase this star. For part A, we need to prove that these two triangles are similar. So you can look at the angles given. If you have two pairs of corresponding angles the same, then you can draw the conclusion AAA easily. So the first pair is given to you because from the given condition you know it. The second pair, BFC, EFD, are also the same because they are the vertically opposite angles here. Of course, if you have two pairs of angles equal, then the last one must be angle sum of triangle. You can just claim it directly. Okay, so now I write the presentation for you. The third angle is angle sum of triangle. Okay, so part A is done and you can refer to the answers here. Next, look at part B. Because the area ratio is 1 to 4, then you can make use of the idea of similar figures to claim that the side ratio is 1 to 2. Because E is the midpoint of AD, then the ratio will be 1, 1, 2. Okay, so it's just a matter of how to present your answer. the things would be quite easy for you. And then the parallel lines can also be proved easily because you have the alternate angles equal here. So this is the idea. How I present, I show you now. Okay, so the first part is to show that BC equals to 2DE using the area ratio. So also AD equals to 2DE given, then you can claim AD equals to BC. Next, we try to prove that AD parallel to BC. We use alternate angles equal to show that AD parallel to BC. So combining these two conditions, you can show ABCD is a parallelogram, opposite sides equal and parallel. Alright, so finally we have finished section 8.3. Perhaps you can feel how tired I am after talking about all this. Okay, anyway, I hope you enjoyed this video. Goodbye.